There are events in Earth's history that scientists prefer not to talk about much. Not because they're unknown, but because they defy every climatic logic we understand. One of these events happened 234 million years ago and received a technical name that hides its true nature, the Carnian pluvial episode. But paleontologists know the truth. They know that once it began, it didn't stop for 2 million years. They know it reshaped all life on Earth. And they know that without it, you probably wouldn't be here today. Try to picture this: basement rocks. The kind that normally lie buried miles beneath the surface, just above the mantle, fully exposed to open air. For that to happen, you need erosion on a continental scale. Erosion caused by rain. Not normal rain. Precipitation so intense that geologists have found undeniable evidence of it in rock formations all around the world. Paleosols packed with amber, the kind that only forms when rainfall massively exceeds evaporation. Continental lakes so large they would make today's Great Lakes look like puddles. Peat forests returning to regions that once were blazing deserts. And all of this lasting not years, not centuries, but millions of years. The Carnian pluvial episode turned Pangaea into a gigantic tropical greenhouse. Swamps spread across continental scales. Rivers overflowed permanently. And in the middle of all this, life had to choose: adapt or vanish. But what caused this climatic madness? Along the western edge of what we now call North America, something sinister was brewing beneath the crust. The Rangelia flood basalts, a massive igneous province, were building up pressure. And when they finally erupted, they released volumes of lava that would make Vesuvius look like a faulty lighter. But it wasn't the lava that changed the planet. It was the gases. Carbon dioxide, in quantities that defy description, flooded the atmosphere. Even by the standards of large-scale eruptions, Rangelia was abnormal. The planet warmed between 4 and 8 degrees Celsius in a geological blink. And here's the disturbing detail. Along with the CO came methane clathrates. For anyone not familiar with climate chemistry, methane is 86 times more potent than CO as a greenhouse gas. It was fuel thrown onto an already uncontrollable fire. The hydrological cycle went into violent overdrive. Continental weathering skyrocketed, and the result, it started to rain. And it simply didn't stop. You don't feel rain underwater, right? So the oceans should have been safe. But reality played out very differently. Carbonate platforms, structures vital to countless marine organisms, collapsed. Animals that depended on carbonates to build shells and skeletons suffered catastrophic losses. Conodonts, those tiny vertebrates with complex teeth, nearly disappeared. Ammonoids, those spiral-shelled cephalopods, took a brutal hit. Bryozoans, algae, crinoids, all felt the impact. And here's a detail most people forget. What happens when you dump fresh water into a salty ocean for millions of years? Exactly, you dilute it. Ocean salinity dropped drastically. For you or me, a small change in salinity is nothing. But for a finely tuned marine invertebrate, it's chemical torture. Homeostasis collapses. Metabolism fails. The Carnian pluvial episode is often called the forgotten extinction. And the oceans were where it struck the hardest. To understand what this rain destroyed, we need to step back. The Carnian was one of 6 stages of the Triassic period. All land was packed into one supercontinent, Pangaea, occupying more than a third of Earth's surface. The rest, ocean, Panthalassa, dominated most of the planet, with the Paleotes filling the remaining aquatic expanse. The climate was extreme in ways our modern minds struggle to comprehend. Most of Pangaea was scorching desert sand and rock beneath a merciless sun. But there were also mega monsoons, seasonal storms so violent that any modern hurricane would seem like a summer breeze. The central Pangaean mountains cut the continent in half, creating continental-scale rain shadows. Some regions were so arid that today's Sahara would look like a botanical garden. The equatorial interior was literally uninhabitable, a natural furnace where life simply could not gain a foothold. But along the coasts and southern regions, where the climate was slightly less homicidal, something fascinating was unfolding. The planet was still recovering from the Great Dying, the Permian extinction that nearly reset evolution itself. With so many ecological niches empty, biological innovation exploded. Rhesuchians ruled as apex predators. Rhynchosaurs thrived as herbivores, making up as much as 60% of fossils. In some formations, Dicynodonts, those iconic tusked theropsids, roamed in herds, and quietly, in the shadows of these giants, small, bipedal creatures began their journey. The earliest true dinosaurs. This was the world the rain was about to completely reorganize. While the oceans struggled with altered salinity, the land faced literal deluges, and not everyone survived. Rhynchosaurs, once the dominant herbivores, were devastated. Their preferred vegetation vanished beneath fast-spreading tropical forests. Almost every family went extinct, except the hyperoid, and even they didn't last long past the canyon. Dicynodonts struggled to these tusked theropsids, which had survived since the Permian, were overwhelmed by constant flooding and rapidly changing environments. Many groups vanished during the event, though their early diversity allowed a few to persist until about 211 million years ago. The Carnian pluvial episode wasn't a mass extinction in the traditional sense. There was no single apocalyptic moment, but background extinction rates skyrocketed. It was a slow death by 1,000 cuts of rain, but destruction creates opportunity. And some groups didn't just survive, they flourished spectacularly. Plants were the obvious winners. When the land abandoned its arid paradigm, flora exploded. Ferns diversified heavily. Conifers spread. Benetitalizan, extinct group of seed plants, rose to dominance. These three groups would become the backbone of Mesozoic flora for the next 150 million years. Forests and swamps grew globally. Massive continental lakes dotted the landscape. And with this explosion of vegetation came an explosion of ecological opportunity. More plants meant more herbivores. More herbivores meant more carnivores. The entire food web reorganized. And some carnivores in particular loved this new aquatic world. Semi-aquatic phytosaurs had a meteoric rise. It's easy to understand why. They were predators adapted to wet environments, and suddenly the entire planet turned into a gigantic swamp. Megaliths formed everywhere. Rivers overflowed permanently. For phytosaurs, it was like inhaling energizing aromatic salts. They diversified rapidly, expanded their geographic range, and ballooned in size, growing large enough to attack almost anything that approached the water. Even medium-sized sauropods had to be cautious while drinking. Honestly, that gives me yet another reason to fear bottomless lakes. Turtles and early crocodilomorphs also made significant strides. So maybe we should thank this ancient storm from 234 million years ago for the fact that crocodiles and turtles even exist today. Without that eternal rain, these groups might never have achieved dominance in aquatic habitats. But the group that benefited the most were creatures that, before the event, were practically irrelevant, small bipeds hiding in the shadows of giants. The dinosaurs in the Santa Maria Formation. In what would become Brazil within Pangaea, Creatures like Styracosaurus hunted small vertebrates. At just 2.25 meters long, it was one of the largest dinosaurs of its time, which says a lot about how modest they were back then. Another pioneer, Buryolestes, confused scientists with its theropod-like appearance despite being a carnivorous sauropod morph. But after the Carnian pluvial episode, everything changed. Dinosaur diversity exploded. Formations that once produced a few genera suddenly held nearly 10. Argentina's Ischiguasto Formation recorded at least 8 different kinds, including Herrerasaurus, which reached 6 meters and became one of the most common predators in its ecosystem. And for the first time, giant dinosaurs appeared. During the Nourian, around 228 million years ago, Lesomsaurus reached 12 meters long and 10 tons. Not much compared to the Jurassic titans to come, but for the Triassic, revolutionary, herbivorous, armored ettosaurs also dominated, specializing in the new conifer and fern-rich forests better than earlier groups. And even the fearsome Rusukians, quadrupedal apex predators, seem to have grown larger after the rains, with genera like Saurosuchus reaching 7 meters and half a ton. The Carnian pluvial episode didn't create dinosaurs, but it gave them the push they needed to eventually dominate the planet. Eventually, like all things, the volcanoes quieted, the rain eased, arid conditions returned, at least in part, but the impacts were permanent. Dinosaurs were given their chance. Modern crocodiles and turtles may owe their existence to that ancient storm. Entire Mesozoic forests were born from the wet ashes of this event. The biological architecture of the Mesozoic was defined by 2 million years of relentless rainfall. So next time the rain falls, remember, 234 million years ago, our planet endured one of the strangest climatic events ever recorded, and without it, the world you know would be unrecognizably different. This is Extinct Aquaria. If this journey through Earth's soggy past fascinated you, the next video will explore even more astonishing creatures that emerged after the storm. Subscribe so you don't miss it, and tell us in the comments which geological event should we explore next. See you on the next expedition.